In the last video, you determined that on average, 14.82% of the total banana weight is due to the peel. Based off your earlier assumption, you think you can use this calculation for your cash registers. But before you do that, you want to check if your assumption is correct. You ask an employee to sample 30 more bananas, and the results look something like this. This time, the average peel proportion is 15.33%, with a standard deviation of 3.66. Knowing what you know about confidence intervals, you wonder if 15.33 is close enough to 14.82 to be considered the same. So you run a one-sample t-test. The results end up showing that it is the same. That is, it is contained within the confidence interval. A one-sample t-test compares the mean of one group of data, considering the confidence interval, with a hypothetical mean. In this case, we wanted to know if the mean from our second sampling of bananas was the same as 14.82%. But let's say we get bananas from two suppliers. You wonder if different environmental conditions, farming practices, and transportation distances between the two suppliers will affect the banana peel weight proportion. So you want to test it out. Now, first of all, you've been arbitrarily sampling 30 bananas in the previous experiments. Sampling and weighing 30 bananas it actually takes a lot of time. And not only are you paying your employee to weigh bananas instead of doing more productive work, but every banana sampled can't be sold. So all this testing is actually costing you money. So you perform a sample size calculation and determine sampling 20 bananas is sufficient. Well, that at least saves a little bit of money. So you sample 20 bananas from vendor A and 20 bananas from vendor B. Your data looks something like this. You know the average peel proportion for vendor A is 15.5 and the average for vendor B is 14.35. But you're unsure if these two means would be considered the same when taking into account the variation in the data. You run a two-sample t-test to compare the means of the two groups of data. Your results end up showing that they are the same. Remember, however, that a t-test only compares means. If you want to know if the variations in the two groups of data are the same, you need to perform an f-test. Remember that two groups of data can have the same means but entirely different variations. Since we're trying to find a golden number to say all banana peels weigh, we need to compare means and variations. So you run an f-test, and it happens to tell you that the variances are not the same. Well, now you want to know if banana peel proportions change over time. Maybe the peel gets thinner the older the banana gets. So you sample 20 bananas again, only this time you cut each banana in half, like this. You weigh one of the halves now and store the other half for later. After a week, you weigh the other half. Ideally, you'd want to weigh the entire banana, let it sit for a week, then weigh it again. But you have to destroy the banana to weigh it, so we had to cut it in half. We also had to remove the stem to make the halves equal. So now your data looks something like this. This is called a paired t-test. Each measurement from week 1 is paired or matched with week 2. You're comparing banana number 1 in the week 1 column with banana number 1 in the week 2 column, and so on. So we want to know if the peel proportion for week 2 is different from the peel proportion for week 1. This is a two-sample t-test, but the data is paired, so the calculation is a little bit different. You run the test, and it shows that the peels get thinner over time.